Questions 11 through 16. Listen to part of a lecture in a geology class.
Mount St. Helens is in the Cascade Range, a chain of volcanoes running from southern Canada to northern California. Most of the peaks are dormant. What I mean is they're sleeping now, but are potentially active. Mount St. Helens has a long history of volcanic activity, so the eruptions of 1980 weren't a surprise to geologists. The geologists who were familiar with the mountain had predicted she would erupt. The eruption cycle had sort of a harmless beginning. In March of 1980, seismologists picked up signs of earthquake activity below the mountain, and during the next week, the earthquakes increased rapidly, causing several avalanches. These tremors and quakes were signs that large amounts of magma were moving deep within the mountain. Then, suddenly, one day there was a loud boom. A small crater opened on the summit. St. Helens was waking up. The vibrations and tremors continued. All during April, there were occasional eruptions of steam and ash. This attracted tourists and hikers to come and watch the show. It also attracted seismologists, geologists, and, of course, the news media. By early May, the north side of the mountain had swelled out into a huge and growing bulge. The steam and ash eruptions became even more frequent. Scientists could see that the top of the volcano was sort of coming apart. Then there were a few days of quiet, but it didn't last long. It was the quiet before the storm. On the morning of May 18th, a Sunday at around 8 o'clock, a large earthquake broke loose the bulge that had developed on the north face of the mountain. The earthquake triggered a massive landslide that carried away huge quantities of rock. Much of the north face sort of swept down the mountain. The landslide released a tremendous sideways blast. Superheated water in the magma chamber exploded, and a jet of steam and gas blew out of the mountain's side with tremendous force. Then came the magma, sending up a cloud of superheated ash. In only 25 seconds, the north side of the mountain was blown away. Then the top of the mountain went too, pouring out more ash, steam, and magma. The ash cloud went up over 60,000 feet in the air, blocking the sunlight. Altogether, the eruptions blew away 3 cubic kilometers of the mountain and devastated more than 500 kilometers of land. The energy of the blast was equivalent to a hydrogen bomb of about 25 megatons. It leveled all trees directly to the northeast and blew all the water out of some lakes. The blast killed the mountain's goats, millions of fish and birds, thousands of deer and elk, and around 60 people. The ash cloud drifted around the world, disrupting global weather patterns. For over 20 years now, Mount St. Helens has been dormant. However, geologists who've studied the mountain believe she won't stay asleep forever. The Cascade Range is volcanically active. Future eruptions are certain, and unfortunately, we can't prevent them.
Number 11. According to the professor, how did the cycle of volcanic eruptions begin? Number 12. Why does the professor say this?
This attracted tourists and hikers to come and watch the show. It also attracted seismologists, geologists, and, of course, the news media.
Number 13. Listen again to part of the lecture, then answer the question.
By early May, the north side of the mountain had swelled out into a huge and growing bulge. The steam and ash eruptions became even more frequent. Scientists could see that the top of the volcano was sort of coming apart. Then there were a few days of quiet, but it didn't last long. It was the quiet before the storm.
What does the professor mean when he says this?
Then there were a few days of quiet, but it didn't last long.
Number 14. The professor explains what happened when Mount St. Helens erupted. Indicate whether each sentence below was part of the event. Number 15. What were some effects of the eruption? Number 16. What can be concluded about Mount St. Helens?